All right, guys. Hopefully you had a chance to calculate that area. Perimeter would be 4 plus 6 plus 8, or 18, which means the semi-perimeter is 9. So this becomes 9. Then you're doing 9 minus 4, 9 minus 6, and 9 minus 8. So if you do some subtraction on there, 9 minus 4 is 5, 9 minus 6 is 3, 9 minus 8 is 1. Multiply all those numbers out. Let me check this. 9 times 5 times 3, and you get 135, which it can be simplified as well. If you divide that, but of course you can see this right now. What's the square root of 9? Well, the 3 could come out of here. You'd have 15 left over. So the exact answer is 3 rad 15. If you can't handle the exact answer, you might get approximately 11.6 square units, whatever the heck they are, square feet, square miles, square inches. So there's Heron's formula. Before you use it too many times, I want you to understand its limitations. Like, it's not always the best method, but it often can be used. You can use it anytime you really want to. There's 3 problems I've got on the bottom of your page. Take a minute and label the sides 6, 7, and 5. 3 feet and 4 feet, and this one's got a right angle up top, as you might have suspected. And then this one's got 3, 3, and 5 for the side lengths. And there's 2 questions on your paper. One is asking you just not to calculate anything, just which triangle would Heron's formula be the most useful for. One of these 3 is like picture perfect for Heron's formula. One of these triangles is picture perfect for 1/2 base times height. And then one of them you could probably do either one. And it's sort of like up to, personal preference, whether you use 1/2 base times height or Heron's formula. I think you'll find Heron's formula can be quick if you know it. Once you get used to it, it can be quicker than doing 1/2 base times height. So, which one's the Heron's formula question? Hopefully after looking at it you go, well, I'm not sure, I'll skip that one. Base times height, well, if you have the base and you have the height, that's the best one to use. This is the only one where you have the base and the height. This is not the base, this is the hypotenuse. You could call that the base and that the height, and this one's incredibly quick to use 1/2 base times height. Anytime you have a right angle, base times height is the quicker one. Base times height divided by 2 is the quickest method on there. So this one is definitely a 1/2 base times height problem. You certainly could calculate and find that's 5 and make this question more messy than it has to be, but I would definitely say that's a 1/2 base times height. This one you hopefully see is the Heron's formula problem. And of course, why is it the Heron's formula problem? It's hard to get the altitude. So that one right there is a Heron's formula problem. This is 1/2 base times height. You can quickly do 3 times 4, 12. Cut that in half and get 6. This is the one where you're kind of in between. Yes, you could draw an altitude and calculate the height on that one, or you could use Heron's formula. Do whichever one you want on that one. I suggest use Heron's formula because it's new, and it's just practice with that method on there. This one's the one, you try to find that altitude, good luck. You'd have to break this up into 2 little pieces, and they'd be messy. So go for it. I think, and I'll put some answers up here. You can pause if you want. You can pretend that's not there if you want. Try to use Heron's formula on that one. I think you're going to get 6 rad 6, or approximately 14.7. Add up the sides, you get the perimeter, cut that in half. So I think the semi-perimeter is 9 again. And then you have 9 times 3 times 2 times 4, and you should get approximately 14.7 square units, wherever they are. Like I said, the middle one's the easy one. That's 6 square feet. Base times height divided by 2. And the last one, you can do it either way. A good time to pause, try this on your own. I think it says in your paper to show whatever calculations you're doing, show them on your paper so I know which method you're using on there. So you can do it either way. You're doing Pythagorean theorem and then base times height divided by 2, show that. If you're using Heron's formula, show what you're doing so I can give you full credit when I collect the notes. I think you should end up with the square root of 17.1875 eventually, which is what, about 4.1, something like that, 4.15 approximately square units. So hopefully those answers make sense. Hopefully you can come up with those values. The reason you have decimals inside here is because when you add these up, you get an odd number. And when you're messing with an odd number for the semi-perimeter, you get sort of messing values in there. You're multiplying 0.5 times 0.5 times 0.5 a couple different times, and it gets a little ugly. So hopefully those make sense. Make sure you've answered these 2 questions. Which one's Heron's formula problem, and which one's base times height divided by 2. And the why part of it, the important part, understanding when is a good time to use Heron's formula. Flip the page over on the back and that's all on your own, 100% independent work. I'll put up an answer key for that on here in a minute. I suggest you pause and try the back on your own. Like I said, I'm going to put the answers up here in a moment. But the back is really just independent work. Should take you maybe 5 minutes, maybe 10 if you're a little bit longer, and there's nothing wrong with taking a few extra minutes on it. I will put the answers up here, like I said, for the areas. That's what you should get for the 4 areas. If you want to pause it and pretend you didn't see that, do that. But you certainly are welcome to check those, or should check those as you work through it. I think they're all correct. We can argue about them on Monday when I come back if you want. And then the bottom questions are asking you to think about, why you'd use Heron's formula in certain ones on here, why you wouldn't. I want you to use Heron's formula for all of them, but certain questions on there you could use either method on there. It's based on what type of triangle it is. So I think this one, if you drew it, would be an obtuse scalene triangle. And they're not all going to be obtuse scalene triangles, so it's it depends on the type of triangle. But that's sort of what I'm looking for, as you see, as a type of answer for some of those. So I'll be back. I've got a part 3 I want you to check out here, which is basically tying up loose ends for things we haven't covered this week. So I'll be back in a moment to cover that. Hopefully things go well with Heron's formula. Maybe you can get the homework started early as well.